Hi everyone, I am Jamie Kristina Zoilon and today I am going to explain to you the brief definition and usage of Floyd Warshall algorithm, the solution and answer to the question. Find the shortest path in graph A and graph B using Floyd Warshall algorithm. So, without further ado, let's get started. Floyd Warshall algorithm is an example of dynamic programming. It breaks the problem down into smaller sub-problems and then combines the answers to those sub-problems to solve the big initial problem. The idea is this: either the quickest path from A to C is the quickest path found so far from A to C, or it's the quickest path from A to B plus the quickest path from B to C. So here is our graph. So here are the steps in order to find the shortest path of graph A using Floyd Warshall algorithm. So the step 1 is complete the initial table by converting sum into infinity. So let us always remember that in this adjacency matrix, the value of infinity represents that there is no direct edge between the corresponding vertices. Now, let us apply the Floyd Warshall algorithm to find the shortest path between all pairs of vertices. And for our step 2, let us initialize matrix D with the same values as the adjacency matrix. So magiging ganito na po yung resulta. Matrix D equals A bracket 0, negative 1, 4, and 2. For B, 4, 0, negative 2, and 8. For C, 3, 3, 0, infinity. And for our E, infinity, 8, infinity, and 0. Now, let us perform the Floyd Warshall algorithm. Let us always remember that for each vertex k in the graph, for each vertex I in the graph, for each vertex j in the graph, if dij is greater than dik plus dkj. So update dij with the new shorter distance dik plus dkj. After applying the algorithm, we have matrix D equals A 0, negative 1, 0, 2, B negative 1, 0, negative 2, 0. And for our C, 3, 1, 0, 4. And lastly for our D, 11, 8, 10, and 0. The matrix D now represents the shortest distances between all pairs of vertices in graph A. So here is our shortest path for graph A. Path A to B to T with a distance of 4. Let us always remember that to find the shortest path between two specific vertices, we must go back to the matrix D. Starting from the source vertex, follow the path with the minimum weight until you reach the destination vertex. Let us all apply the steps that we have learned from graph A in order to find the shortest path in graph B. Again, our first step is to construct the adjacency matrix for graph B as follows. So here is our adjacency matrix. So for vertex A, 0, 8, infinity, negative 2, and positive 2. For vertex B, infinity, 0, 5, infinity, and infinity. For vertex C, 3, 5, 0, 2, and 3. For vertex D, infinity, infinity, -1, 0, and infinity. Lastly, for E, -1, infinity, 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 and 0. Again, in this adjacency matrix, the value of infinity represents that there is no direct edge between the corresponding vertices. Now, let us apply the Floyd Warshall algorithm to find the shortest path between all pairs of vertices. And for our step 2, we need to initialize matrix D with the same values as the adjacency matrix. So here's our matrix D. And now for our step 3, we need to perform the Floyd Warshall algorithm. Let us always remember that for each vertex k in the graph, for each vertex I in the graph, for each vertex j in the graph, if dij is greater than dik plus dkj, update dij with the new shorter distance dik plus dkj. So, after applying the algorithm, we have matrix D equals vertex A 0, 2, 3, -2, and 1. For vertex B, infinite, 0, 5, infinite, and for our C, 3, -1, 0, 2, 3. For vertex D, infinite, infinite, -1, 0, infinite, and for our last vertex, which is VE, -1, 1, 2, -3, and 0. And so for our last slide, the shortest path for graph B is path A to path E to path D and to path C. And the shortest distance is 3.